Okay, so we're going to keep with reading in data sets within R. I believe we had stopped with the CSV example here. We at times have all the character strings be treated as factor variables, and that usually is the case. However, we can use the as-is function here to reverse that and make selected columns not be treated as character strings. Sometimes this is appropriate, sometimes not. I'm not going to emphasize this. Finally, if we have a start date in our example here, then we can read this in as a character string or as a literal or as a non-character string, and then convert that start date back to a date. So remember that as date function, which would do the conversion according to the specified formatting of the date. And then we can bind our original data, which is stored here, with that column for the original start date that really isn't interpretable as a date variable, bound to basically replace that. So that -7 takes out the original D start, and then we put in the new version of the start date. Finally, you can use the command file choose. What this will do is allow you to specify the file that you read in. This is, I guess in certain applications this would be useful, but you should just know that that's an option for you. Take a moment and try out this code with the example.csv and make sure that you understand each of the commands. We are going to continue with data frames. Once you've read in your data frame into R, we can investigate its columns or variables, and we can also investigate the search path. So more or less the search option gives you a list of attached packages and R objects that are typically going to be data frames within R. So let's just kind of look at an example of this. The CO2 dataset is by default in R. We can take a look at a particular variable, which here happens to be called update, can say compute the mean on it, and then we can search the path. In my example, I just went ahead and on my installation of RStudio here, I searched the path. Here I'm getting what packages I happen to be using, and those locations. So you can see I'm using a certain number of packages here, and I know which ones are available to me. Okay, so let's say we want to be working with this data frame, CO2. We can use the attach function to attach that data set, and then this allows us to get at variables without having to use the CO2 $sign as a precursor on the variable name. So for example, here we had to use CO2 uptake. Down here we just need to print out the word uptake. It will look first in CO2 to see if that variable update exists. If not, it may give you a message about that, but search should now show uptake as an object within R. Okay, I'm gonna demonstrate this in just a moment. Of course, detach does the opposite of attach, so that once you've attached a data frame, it's a good idea to always detach it when you're done. So let's investigate this again. Okay, so here you can see below where I ran the search function. Originally, I attached CO2, typed it wrong the first time, you can see, but I typed it correct here. So now CO2 is attached. So what's changed with our search function? Notice the path that we went through before. So remember, this search function kind of gives you a path or a trail that R goes through in order to find objects. Okay, so it's going through this trail. Now notice second, after the global environment, which I'm not going to go into a lot of detail here, now our path has changed. So we go from before the global environment, which like I said, I'm not going into, to now CO2. So that pointer, you may not be familiar with the concept of a pointer, and that's okay, but you can just say now it goes straight to CO2 and anything contained in CO2. So that when I run mean uptake, it knows that uptake should be taken directly from CO2 and doesn't have to go searching any further than that. So this is the use of using the search function along with attach so that we really know the path through which R will go searching for objects and or functions. Here it's just an object, a variable name, but it could also be searching for functions such as mean in one package may be different than the global function for mean, and so a particular package may have a differently defined function for mean, which I would not recommend doing as a package author, but I'm sure that happens quite often because you have that freedom within R. All right, so back to the notes. Caution. I've talked to a few people who kind of dabble in R and they say, oh, but aren't you supposed to always attach a data frame in R? And I say absolutely not. If you're just working on one data set within a session and you're really just going to do simple analysis, then yeah, use attach. However, in many data sets, there are very common variable names that get used routinely, like X and Y or TRT for treatment or response or anything like that. And it can cause a lot of confusion and problems and mistakes in your analysis if you're not quite careful and you don't keep a very clear trace of what your objects are getting pointed, how your objects are getting pointed to. Okay, so whenever you have multiple duplications of names, I should just say duplications of names, you'll often get a warning, but often you really don't know. Then also in much analyses where you're not just computing simple statistics like a mean or a variance, like if you're doing a generalized linear model, using the GLM or LM function here, it has a data argument, so there's actually no need to attach a data frame. So I just caution against it almost all the time unless you're just doing something short and quick and easy with some variables. What I recommend instead is using the with argument. So if you have a bunch of functions that you're going to apply over and over and over and you want it used to where you don't have to make explicit mention of your data frame with the $ over and over when you refer to variables, use the with function. And this is a lot better and a lot less confusing than the attach if you have multiple data frames running all at one time. However, if you do use attach, always call detach. That's just good programming. All right, so here's an example of how things can go wrong with attach. So here we're going to define something in the global environment. Remember that GL function from before? And it has labels type A and type B. So now we're going to attach CO2, the one that I had attached before. Type is going to be getting it from the global environment, which we just defined up here, rather than CO2, okay, even though we did attach. However, if you use the with function like I generally do recommend, you always know what is getting pointed to. So it's no denying here. We are pointing to CO2, our data frame, and we're going to be using the variable type and plant. So there's no confusion of that type and that type, okay? Similarly, we can do the same thing with the code below. A box plot using uptake and treatment. Well, there's going to be no confusion of this treatment and some other treatment variable that maybe you've defined in another package or defined within your global environment. I think this is clear and transparent, whereas this I'm not sure if I just looked at that code that I would be sure where type was coming from, if it's global or if it's CO2. I only know because I ran it. Okay, so be very, very careful. Another way you could know, by the way, is just run that search function. That search function will tell you it's going to the global environment first and then to CO2. So you know you're going to be wrong here, whereas you're going to be right here. So that's my caution about attach. It just gets you in trouble. It's like one of those friends you don't want around because you always get in trouble with them. All right, so now if you do just a model, you can see why we don't need attach most of the time, because we make explicit reference to our data frame CO2, and there's, again, no mistake. All right, so we can also import data sets using the scan function. I'm less experienced using this, I guess I'd say. It's a lot more flexible than read.table, but most of the time read.table works perfectly fine for me, and I find scan a little bit more difficult to use. But let's say we did have some strangely structured data set that has a different number of values on each line. This is a case where you would want to use the scan operator. Here you tell them that the separator is a new line, and you're just going to scan through that document and save it in lines. Another way you could use scan, if you had just like a really strangely formatted data set, odd data, hence the name, is you could just use the scan function within this user-defined function here. What this is going to do is it's going to start at 0 and skip 0 lines first. Then it'll skip 1 line, so that means it goes to the second line. Then it'll skip 2 lines, that means it starts at the third line, and so on. A lot of this code you're not going to understand yet because we haven't talked about user-defined functions, but this is just another use of scan that could make sense. Most of the time for this class, though, just keep with read.table. If we export data, it works almost exactly like read.table. Another reason to stick with read.table is we've got this nice parallel here. Write.table, you take the object that you want to save, specify the directory and the name, specify the separator, and whether or not you want names for the columns and rows. Okay, pretty simple code. There's a wrapper function for read.table, which is read.csv, that's specifically for comma-separated files. Finally, we can output console. I used to use this a lot. The function capture output will return your output, your current output, to a file. Or you can use sync to divert all of your output to a particular file. So let's say we generate some X's, we generate some Y's, then we fit them, okay? We can capture the output of that summary function for fit, and we can also specify where it goes to, so we could name it a particular value. Sync does the same thing, but it will send all output to a file, not just the expression. Okay, so here the mean, the summary, and then you stop sync. All right, I see this is kind of old stuff in my point of view. Now with using RStudio and the Markdown environment, we really don't need to do these lower level ways of getting console output, because our console output gets directly put, if you recall, into PDF, Word, or HTML files.